Alright, welcome to this video. We're going to be talking about complex numbers and two concepts on complex numbers. Assuming you've already been introduced to them a little bit and that you understand that a complex number contains a real component and an imaginary component. You may have seen that a plus bi is the standard form of a complex number. Here's an example of a complex number, 5 plus 7i, where 5 is the real component of it and the 7i with the I in it is the imaginary. All right, sorry about that handwriting. Anyway, so what we're going to do is we're going to talk about two things with respect to complex numbers. We're going to talk about graphing complex numbers and finding the absolute value. And you really can't understand the absolute value portion of it until you figure out how to graph one. So with that said, let's go and figure out how to graph it. Now, really easy. If you go back to, I don't know what grade level they start working on this, really early these days, but if you wanted to graph the coordinate 4, 2, for example, you would go over 1, 2, 3, 4 and up 2 and put a point there, and that would represent 4 on the x-axis, 2 on the y-axis. So here's my x, here's my y. Well, it's the same deal. Watch this. Here's my example of a complex number. It's 4 plus 2i, where 4 is the real component and 2i is the imaginary component of this. Okay, and instead of an x and a y-axis, we have a real axis. So that's going to replace the x-axis, and we've got an imaginary axis, and that replaces the y. It's just like x, y coordinates. So 4 plus 2i, we're going to go out 1, 2, 3, 4, and up 2 on the imaginary axis and plot a point. So this is considered not 4 comma 2 anymore, but 4 plus 2i. That's point A. Okay, point A right here. All right, and let's take a look at point B. That's negative 3 minus 4i. So where do you think that would be? Again, we're just going to pull out the A and the B portion of this A plus BI standard format. So A is negative 3, so it's going to be negative 3 on the real axis, and that's a negative 4. Some people say minus 4, but it's minus 4 and negative 4, same thing in the context here. 1, 2, 3, 4. We're going to put a point. This is point B, or known as negative 3 minus 4i. All right, that was pretty simple, would you say? All you got to remember is just like xy coordinates, pull out the real component, the imaginary, plot it as if you're plotting an xy axis, but instead we're on a real and imaginary axis. Easy enough. Now that you understand that and see how easy that is, we can do this other portion, which is finding the absolute value of a complex number. Now, most of you know that the symbol for absolute value is a couple of bars. So if we do a couple of bars and say the absolute value of negative 8, most of you will tell you that's positive 8. Okay, and where you get that is, where is negative 8 in relation to 0? How far is it from 0? Well, you go 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's 8 units away from 0, and that's what absolute value is. It's in mathematics, it's defined as how far something is from 0. But now we just talked about these complex numbers. They're made up of two components, so when we put those on a number line, we really don't. We put them on a graph, a grid instead, called the complex plane. So 4 plus 3i, my example, how did we graph that again? That was just like x and y. We go 4, so we go over 4, and we go up 3, and we plot it right there. So we had to go over 4, and we had to go up 3 to get it to this location where 4 plus 3i is located. Now what I want to know is the absolute value of this number. We said an absolute value of a real number is its distance from 0. The absolute value of a complex number is its distance from, I want to say 0, but look, it's this portion right here, and that is not just 0, it's 0, 0, otherwise known as the origin. Okay, so it's its distance from the origin, and you think of that as 0, 0, or 0 plus 0i. And so what we're going to do here is we're going to find out the distance that is from 0. So let's see. We want to go from here all the way to the origin. Now how do we do that? Well, we've got to I want you to notice there's a triangle there. We went 4 units over this way. We went 3 units up. It is a right triangle, as bad as my drawing was. It's a right triangle. And how do you find the longest side in a right triangle? Well, you know what? It's just like, specifically, it's the Pythagorean theorem. Pythagorean theorem. And some people may notice, you know, when we're talking about coordinates, we would use the distance formula, which is just a variation of the Pythagorean theorem. Now, the distance formula seems a little complicated sometimes, but we know that the Pythagorean theorem is a squared plus b squared to get c squared. Okay, so you take one leg, square it, you add the other leg, square it, you get the hypotenuse squared. We don't want to know the hypotenuse squared, we want to know the hypotenuse itself. So to get c by itself, you have to square root this side and therefore square root this side. So really, the distance that we're looking for, c, is equal to the square root of a squared plus b squared. So that's going to become our formula, the square root of a squared plus b squared. Now somebody was thinking ahead when they decided that the complex number was in this format a plus bi, because a and b here represent the same a and b you would use in a right triangle with the legs, both legs squared. So all we're going to do is take the 4 and the 3 out of that, and 4 squared plus 3 squared, but get the square root of it. So 4 squared is 16, 3 squared is 9. We're going to square root it. We got to add 16 and 9 first, so it's square root of 25. And of course the square root of 25 is, whoops, not 25. It is 5. Okay, so that one is 5. All right, let's take a look at just a couple more. We'll do it without the grid this time. So if you had 7 plus 8i, just kind of making something up here. This is the a, this is the b. If I had to plot it, it would be over 7, over 7, up 8. I go a little farther. And I want to know that distance right there. Oh, that's horrible. I'm working on this tablet. It's not working so good here. All right, and so we're going to go, the formula was, for the absolute value of a complex number, it was the square root of a squared plus b squared. So we got square root of, well, a represented the real component, and b represents the coefficient of the imaginary, or the imaginary component. All right, so that's 8 squared. So we've got to do what's inside here first. We got 7 squared is 49. 8 squared is 64. We add those together, we get 113, I believe. Square root of 113, if we grab a calculator with that, it does not simplify it, so that's going to be our answer. And if you needed to toggle to get a decimal answer, you could, but this would be the answer you probably most likely to be looking at. All right, and I want to show you one with a negative. Negative 4 minus 2i. All right, simple enough. If we were on a grid, here we go, negative 4, 1, 2, 3, 4, and down 2. That would be our point. We're looking for how far is that from 0. And so we would go over 4 to get over here. And some people might say negative 4. That's true. And we would go down 2 units here to get to this. Some people might say negative 2. All right, so let's go with those. So it's a squared. We'll go negative 4 squared plus negative 2 squared. Now, one thing I'm going to do here, you might say, that doesn't make any difference, but I'm going to put parentheses around here because I want to make sure that that negative gets included in the squaring. So if you take a calculator and you put negative 4 squared in it, most calculators will tell you it's negative 16, but if you put parentheses around it and say include that negative in the squaring, you're going to get positive 16. The bottom line is, every time on these, whether they're negative or positive, when you square it, you're going to get a positive. So it's the square root of 20, and if you simplify that, it comes out to 2 root 5. And that's our answer, 2 root 5. If you don't know how to do that, let's see, we're just taking that 20 and we're splitting it up into 4 times 5. And the 4 goes down to 2 and 2. We're looking at all these prime numbers. You find out we got a pair of 2's in there, so that gets out of the root, the radical symbol, and the 5 is left in there. That's where we're getting that 2 root 5. Okay, have fun with it.